Assalamu Alaikum. I'm Abdullah Nazmus-Sakib, a student of Jahangirnagar University, majoring in computer science and engineering. Recently, I completed an IoT and Robotics course conducted by Edge. As part of this course, I worked on a project called Power Management System. Here it is. In this video, I'll explain what I have done in this project, how the system works, and why it is beneficial to users. First of all, I want to answer a question, that is, why an user use the power management system. As we know, before using any electronic device, it is essential to understand the problem it can solve. Here is the problem this project can solve. First one, raising electricity bill due to inefficient energy usage. Second one, lack of real-time monitoring and analysis. Let me give you an example. Many households and businesses face high electricity bill because they cannot track their energy usage. They need a way to monitor energy consumption in real life and make better decisions to save electricity. Moral of the story, high energy wastage due to uninformed usage, no visibility into which devices are consuming the most energy, difficulty in optimizing energy usage without real-time data. And the solution. To solve this problem, I built a smart power management system. It uses sensors like CT, current transformer, and PT, potential transformer, to measure voltage and current. It calculates power consumption and estimates electricity cost. It displays real-time data on a web interface accessible via smartphone or computer. If you want to say in short, then monitor energy usage in real time, calculate power consumption and cost, provide data accessible from anywhere. Now, question can arise, how I built this prototype. Let's go and open this magic box. But before opening this magic box, here is an OLED display in front of this box that will show the output result of this prototype. Now open it. Yes. Look at this. Here is one ACS712 as current transformer to measure current flow through device, and this one is ZMPT101B as potential transformer to measure voltage. This one is a 4-channel relay to control AC load, and the final one is this one is ESP32 node MCU, act as the brain of the system that treat the current and voltage by using CT and PT and calculate the power which is consumed by an individual device, and also calculates units and per hour cost and send it to the cloud, and this OLED display the result as an user can observe which device consume the most energy. Now discuss the feature of this system. Real-time energy consumption monitoring, electricity cost estimate, cloud-based data logging, and alert for high consumption, device control using relay. If we want to say the real-life application of this prototype, then it can monitor household appliances to reduce electricity cost, manage power usage in office and factories, identify high energy consuming device, contribute to sustainable energy practice. From all of my previous discussion, I can say that this smart management system helps users optimize their energy usage. It reduces the electricity cost and support sustainable practice. It's ready for real-world uses in homes, office, and industries. Let's see the live demo how this prototype works. First, from this, this one is input terminal and this one is output terminal. Now connect it. Let's have a look. Here is the AC source. I just connect and power. And for the node MCU, I connect a AC charger that produces a 5-volt DC that gives the power to the node MCU. Now connects. Look, it is starting. Here is the load, a 100-watt bulb that I'm going to connect the output terminal. Before connecting, I want to show that here is the output initially. Voltage 239, current 0, power 0, energy 0, and cost 0. Initially there is no output, so there is no current flow, as the power, energy, and cost those are also 0. Now connect the output. Look at this. Now look at this display. If it's visible to you, then the heading is power management, voltage 240, current passing through this device 402 milliampere, power 95 point something watt, energy or units 0.1 kilowatts, and cost. If this 100-watt bulb run for an hour, then it will cost 1.2 taka. Okay, let's see how to control it through the blink, and how an user can monitor real life of an individual device from anywhere of the world. Here you can see that this blink console provides the online live monitoring system. From this, an user can monitor his device. That I recently connect a 100-watt bulb to my prototype that consuming 402 or 6. It fluctuate average 400 milliampere current consuming, and the power consuming 98.0 watt, and the units is 0.00 watt. And if the 100-watt bulb run for an hour, then the cost will be 1.28. For this interface, an user can monitor his system, or an individual device can monitor from anywhere of this world.